years you want to talk about. Whenever you're doing something over and over again, multiplying or dividing, you're talking about exponents. Okay? So what we're doing is we're using this time in the exponent spot to represent that we're going to keep multiplying 0.95, keep finding 95% of the value over and over again until we're no longer interested in doing so, however many years that takes. Because we've sold the car, we've lost the car, we've wrecked the car, we've given the car to a relative. Crashed the car off the Grand Canyon. Using more familiar notation, this is the same thing as f of x equals 20,000 0.95 to the x. All right, and this is also the same thing as in your calculator, y sub 1 equals 20,000 0.95 hatch mark x. They all mean the same thing. This is how I'd expect you to write it on the test when I said to talk about the model. I might also ask you to graph this. This graph is going to look like an exponential decay graph, that airplane landing. What is the difference between this and when we graph this using lines? Think back, we did the same sort of problem with lines. And when we did it with a line by, it worked out the way you were figuring it out. You were getting a linear depreciation when you were taking the same, when you were taking 5% of 20,000 each time, because you were going to get a negative slope. You were going to take off 1,000, then another 1,000, then another 1,000. You were going to keep. It would have worked out that way if you kept going. This won't get you a slope. This gets you a different amount of change each time. What are some differences between that?
Well, with this, it's never going to be it's never going to make contact with the x-axis.
Exactly what I was looking for. Yes, and what I forgot to add to the review is the asymptote. I rarely ask a question and get the exact answer I want. This has an asymptote. Okay, this will never hit 0, and as long as the Jeep keeps working, this is more realistic. Okay, things don't usually lose the exact amount of value over time. At some point, they level off. All right. And whereas that line, if you kept following that line forever, eventually the value of the Jeep would hit 0 and then become negative. That can be accurate. Has anyone ever had a car get so bad they had to pay somebody to come get it? And it wouldn't run anymore?
I never had a car.
Okay, that's right. I was thinking in your families. Pardon? Your cousin? Okay, maybe a line would have been a better description of a car that actually lost value, then was equal to 0. See, linear depreciation, which we did before, starts at the value of the car, and that equation eventually has to graph something that hits the x-axis and keeps going. Let's actually graph this. Let's not graph anything linear. Good question though. Let's actually graph this situation, which means we're graphing this. I'm going to make my little chart. What 3 numbers am I most interested in this case, based on the guidelines I just gave you?
1, 2, 3.
Not 1, 2, 3, because we don't have anything added or subtracted to the x. Or the t. What are the 3 numbers I said you should start with?
Negative 1, 0, and 1.
Negative 1, 0, and 1. Actually, Saul, you may have been...
Because isn't it going, since you have like years, positive years, that are going forward?
It's a good point. Saul is an excellent point. Negative 1 doesn't make as much sense for this one. And which one does make more sense, do you think? 2. Okay. What happens when we plug in 0? We haven't bought it yet.
20,000.
Yeah, we get 20,000 exactly. Next to negative 1, I'm going to put Saul says not relevant. And he's right.
Which one are we plugging it into?
Well, it depends. If you've got your calculator out, you'll be plugging it into something like this. If you're working on paper, it might be this or this. Doesn't matter, actually. Because these 3, it doesn't matter because these 3 all tell you to perform the exact same operations.
And y is like t? No, x is t.
X is t.
Good.
X is t in this case. And when you work it out We'll probably use this. We put in 1, we just figured out, and we got 19,000. We put in 2, we figured out, we got 18,050. What happens when we put in 3?
$17,147.50.
Well read. Now, where's the asymptote on this graph? I told you what the asymptote usually is and what moves the asymptote. It is at 0. It is at the line y equals 0 is the asymptote. And what would change that? Forget about this problem for a minute. What would change that?
If there's anything after the 0.95, anything after that.
Right idea, wrong letter. It's the h.
Yeah.
The k is what's added to the t or the x. If there's something directly added to it up in the exponent area. If there's something just added to the end that's not part of the exponent, then that would change the asymptote. We don't have this. For this graph, I'm not going to look for a huge degree of precision on this. I'd expect you to label something reasonably well. As usual, I'll give you a graph that'll hopefully include the area that you need, so that'll be a hint. 18, 17, 1, 2, 3. So we start at 20. We go down to 19. At 2, we go down to a little more than 18. A little more than 17 at 3. And I expect you to get the curve and indicate that you know you're heading towards an asymptote. And that would be a good enough level of ability for this, artistic ability for this graph. I will also, I want you to label your axes. So this is value. This is time. And I'll tell you if I want you to label any particular points. And I'll tell you what points those are. Does that make sense? Questions on this? And I'll do one very quick growth one that's similar to what you've seen before. No questions? You guys are good? Okay. Now, take 2. Exponential growth. Okay, Maya, here's an example that I think you'll be glad this is exponential and not linear. All right, here's open. Exponential growth. You put $150 in a 5% savings account. The 5%.
5% is really good.
5% is amazing these days. You know what's funny is when I was a kid, 5% was like nothing, but credit cards and loans had much higher interest rates as well. Like you could easily get 5% on a bank account when I was a kid, but if you got a credit card, it was like 19 or 20% interest. Now everything's lower.
Because I was talking to my parents about starting a savings account, and I was.
What are you doing, like 2, 3?
What?
What are they offering, like 2 or 3%?
Well, they were just saying that we would probably only be able to get 2 or 3%.
Yeah, and that's you get more if you put more money in.
Yeah.
To get like 4% now, you have to put like $50,000 into something. Actually, that was a year or 2 ago. I wonder if you can even get that now. Okay, the 5% is determined each year and added to the original amount that's in there. Now we're going to assume you don't deduct anything because then nice neat math equations no longer model the situation.
Although deductions would be more accurate to real life.
Oh yeah, stuff goes up, stuff goes down. We'll get to compound interest. But that's for now. This is what's called simple interest, by the way. I won't distinguish on this test. The next test will do some compound interest. But
Learn about finance.
a little bit. Okay.